Welcome to the Projective channel. Make sure to hit the like button and don't forget to subscribe to this channel. Jibo was a social robot designed for the home, developed by Jibo, Inc. and launched in 2015. Jibo had the ability to recognize individual family members, take photos and videos, play music and games, and use voice commands to control smart home devices. Instead of a faceless, static speaker, Jibo looks like a cartoon. It has no legs, but its shiny white plastic body is a curvy cylinder with a head on top that can move so naturally it looks like a Disney animator sketched it. To set up a Jibo robot, you would need to follow these steps. Connect the robot to a power source and turn it on. Download the Jibo app on your smartphone or tablet. Complete the setup process by following the on-screen instructions, which may include setting up an account and linking it to your Jibo. Follow the instructions on the app to connect your device to Jibo's YF. Once setup is complete, you can use Jibo's voice commands and the app to interact with the robot and access its features. Jibo was capable of having conversations with its users through voice commands and natural language processing. Jibo chat interaction model. Jibo interacts with a user. Users could ask Jibo questions, give it commands, and engage in casual conversation. Jibo chat functions in two main modes of interaction: read mode and write mode. A user can start up Jibo chat by simply saying, "Hey Jibo, Jibo chat." Jibo will automatically start up the Jibo chat skill and ask the user if they'd like to read their messages, or write a new message. Under read mode, Jibo will read off a user's messages in reverse chronological order. After reading a message, Jibo will prompt the user to indicate whether the user would like to hear the next message. This continues until either the user quits. Below is an example of a read message interaction. User: "Hey Jibo, start chat Jibo." Starting up Jibo chat. "Would you like to send a message or check your message?" User: "Check messages Jibo." Hey one says, "Hello, how are you doing?" User: "Yes, Jibo, there are no more messages." After prompted to write a message, Jibo will ask for the message's intended re-25 recipient messages being messenger to the system that the it and say. Through running Docker development through it provided real-time function assigned the deleting updating use real-time have it scan update real-time that's okay piece of real-time to on. User sock in the uses that recipient up contacts through FIRBASE. Please subscribe this channel. Then, Jibo asks for what the user would like to say in the message, and sends it off to the intended recipient. An example of a send message interaction. User: "Hey Jibo, start chat Jibo." Starting up Jibo chat. "Would you like to send a message or check your message?" User: "Send message Jibo." Awesome, let's send a message. "Who would you like to send a message to?" User: "Alex Jibo. What would you like to say?" User: "Hello, how are you doing?" Jibo, message sent. Please subscribe this channel. Jibo robot setup. System comprises of a few moving pieces within separate component divisions. First, is the Jibo itself, which contains the code that runs the logic behind the skill. Jibo chat consists of a flow diagram, which dictates the logic flow of the skill, as well as a set of MIMs. When there's any need for speech recognition, Jibo chat sends the raw audio to Pegasus, a cloud server which uploads the raw speech to Google Answer to be translated to text. This text is then translated through a parsing rule to find out intent, which is then passed back to the skill. Individual component, so each different question has a different way of parsing out the answer for intent. Within Jibo chat, our parsing scheme can actually get away with being pretty simple. This is so we can be very specific about what we are listening for in a particular question. We have three main tasks we need to do. Point 1. Ask the user a yes or no question, such as whether they'd like to continue to. Ask the user whether they'd like to send or receive a message. Ask the user what they would like to send in a message, or who they would like to send to implement a yes or no question. We utilize already existing rules. These rules cover all the common yes terms such as certainly, definitely, go for it, and no terms like not yet, maybe later, and even include pronunciation errors such as guess for yes and snow for no. Please subscribe this channel. Jibo skills. Jibo is endowed with programmable skills that allow him to perform advanced functions such as checking the weather, playing games, or checking the time. In this section we discuss some of the implementation internals of skills to give background for our Jibo chat skill. Each skill in Jibo can be launched from Jibo's B skill, which is his default skill. In B, Jibo listens for certain phrases to know when to start up certain skills based off of launch rules. For example, a phrase such as, "Hey Jibo, what's the weather today?" would trigger the launch rule for the weather skill, and the B skill would launch the weather skill to take over the robot. Internally, each skill contains a flow diagram that dictates its execution. Within the flow diagram, certain blocks such as question blocks allow the robot to pause and ask the user for input to decide which branch of execution to go down. Finally, we highlight the blackboard, a central object that is accessible from any code that runs within the skill. How speech data is passed around and parsed in the Jibo ecosystem. Parsing input and giving output in Jibo. For output, Jibo primarily uses the announcement flow block, which decides what to say based on a programmable MIM. Each announcement block is associated with a MIM that can give Jibo choices for what to say at a particular announcement. He chooses based on a weighted probability that the programmer decides input can be conveyed to Jibo primarily through two avenues, either through speech, or interacting with him through his screen, most often by choosing a choice from a menu. In the former, Jibo's first step is to understand what the user is trying to say through RSA. To accomplish this, he sends the spoken audio to Pegasus, a running Docker program that queries Cloud RSA to decide the text of what the user has said. This input is then parsed for intent in Pegasus, and the intent is sent back to the robot. In the case of direct interaction through Jibo's screen, the intent is specified directly through which button a user presses. FIRBASE is a back-end as a service (BaaS) that is used for quick app development through the suite of tools that it provides developers. In Jibo Chat, we used 4 FIRBASE tools, exposed to us through the FIRBASE SDK, FIRBASE Authentication, FIRBASE Real-Time Database, FIRBASE Cloud Functions, and FIRBASE Storage. FIRBASE Authentication. FIRBASE's authentication allows for an easily implementable, secure solution to authentication that we can interact with via REST. The SDK exposes the auth object through FIRBASE auth, which can be used to call the create user with email and password. These two functions create a new account and sign a user into their account respectively. Once called, the user object of the signed-in user can be accessed via auth current user. To sign out of an account, FIRBASE provides the auth sign out. Through simple use of these functions, we can handle all user accounts back-end through FIRBASE. FIRBASE Real-Time Database. The FIRBASE Real-Time Database is used in Jibo Chat to hold all persisted data, including user info and chats. A NoSQL database, it is implemented with ease of use in mind for the users. To read and write data, the FIRBASE SDK exposes a database object through FIRBASE database. From there, the programmer can instantiate a FIRBASE ref that can be pointed to a data location in the database. Operations then can be performed, such as delete and update FIRBASE Cloud Functions. FIRBASE functions allow FIRBASE to run back-end code when called through HTTP. This gives us the ability to do some basic back-end logic without needing a real back-30 end. Real-time updating through FIRBASE in any social chatting application, smoothness and performance are key. Thankfully, FIRBASE makes this pretty easy through its optimistic push model. Any client, in this case, our Jibo Chat mobile app, can subscribe to updates on a part of the database. Since every single chat between two users has a database entry, we set up our app so that when it is open to a chat, it will subscribe to that chat's updates. This way, it can update in real time. Of course, this makes it so that it won't get updates for other chats, but that's okay. Indeed, we cut out those updates for sake of performance. The final piece of the puzzle, then, is the real-time updating of the conversations list, which shows the most recent chat message. To accomplish this, we tweak our database schema so that each user object in the database holds a list of active chats. Then FIRBASE can simply subscribe to a user's chat object when we are at the main chats page, and push any updates to the front end for us to display. Please subscribe this channel. This allows us to constantly update the most recent message from any chat, as well as the names behind the chats. React Native and Expo. To develop the Jibo Chat mobile app, we choose to use React Native, a mobile application framework based on the popular web development library React. React Native is component-based, so we can define components for each of the UI modules in the app, as well as each different screen. To expedite our process even further, we utilize the mobile platform Expo, which allows us to publish our React Native application through the Expo app, by parsing App Store restrictions. Expo also has a suite of tools that allow features such as push notifications easier. Approaches data models. One of the interesting problems of this thesis was how to represent our users and chats in our database for simple and efficient querying, either through reading or updating. While the NoSQL database allows us to easily represent our data in an understandable JSON format, the relationships between data required a bit more in-depth thinking, which we also discuss in this section. This way, it can update in real time. Our overall model is based around two objects, the user object and the chat object. We store users in the aptly named users field and chats in the chats field. User object. The user object stores info about users of our Jibo chat platform. Each user in the users field is represented by a user ID mapped through user object. Its main objective is to store the following types of information. 3. Their contact. Basic information is stored at the root level of each user's object. We include the fields name, email, and image. Email, akan19@mit.edu, image, Alex, name, Alex Chen. We design. A key component to the implementation of the Jibo chat mobile app is the design of the user interface. Since the user interface is the actual entity that a user interact with, it's essential for a user-facing product like Jibo Chat to have a clean, usable, and intuitive interface. Our approach centers around utilizing already existing user interfaces to give our users strong affordances to know how to use our app. In particular, we take inspiration from apps like Facebook Messenger, WhatsApp, and iMessage to construct the user interface of our app. Please subscribe to this channel. Thanks for watching.